Good morning. Last class we discussed first three types of the heat treatment of steel, that means annealing, hardening and tempering or quenching. Today we are going to discuss about remaining three types of the heat treatment of steel. First one, normalizing. What is meant by normalizing? Normalizing means it is the process of heating steel to a definite temperature, that means above its higher critical temperature, and allowing it to cool gradually in air. But in the case of the quenching process, cooling is done with the help of the water or brine water or oil. The main purpose of the normalizing is it recovers the homogeneity of the steel structure, it refines grains, it removes the internal stresses, it increases the toughness. Normalized steel is suitable for the use in engineering works. So, a normalized steel work will not be as soft as annealed job of the same material. Also, normalizing takes much lesser time than annealing process. The next one, carburizing. The mild steel article is taken in a cast iron box. That cast iron box containing small pieces of the charcoal, that means carbon material. It is then heated to about 900 to 950 degrees Celsius and allowed to keep it such as for sufficient time so that the carbon is absorbed to required depth. The article is then allowed to cool slowly within the iron box itself. The outer skin of the article is converted into high carbon steel containing about 0.8 to 1.2 percentage of the carbon. The main purpose of this normalizing process is to produce hard wearing surface on steel article. The next one, nitriding. This is the last one. Nitriding is the process of heating the metal alloy in presence of ammonia at a temperature to about 550 degrees Celsius. The nitrogen obtained by the dissociation of the ammonia combines with the surface of the alloy to form hard nitride. So, nitriding is the process of the heating metal plus ammonia in the presence of the temperature at about 550 degrees Celsius, so that metallic article is converted into the nitride products. The main purpose of the nitriding is to get super hard surface. The next, classification of the alloys. So in the previous chapter we discussed the heat treatment of alloys and the types of heat treatment of alloys. Heat treatment of alloys can be classified into 6 types: annealing, hardening, tempering, normalizing, quenching, then nitriding process. The next, move to types of alloys. Based on the type of base metal, alloys can be classified into 2 categories. One is ferrous alloys and one is non-ferrous alloys. Ferrous alloys means it contains iron as the major constituents, but in the case of the non-ferrous alloys means it does not contain ferrous as the major constituent. Then alloys can be classified into 2 categories: ferrous alloy, non-ferrous alloy. Ferrous alloys example nichrome, alnico, stainless steel. Non-ferrous alloys example solder, brass, bronze. So nichrome means nickel chromium combination, alnico means aluminium nickel cobalt combination, stainless steel chromium combination. Then brass, bronze, copper with combined with zinc, tin metals. Then ferrous alloys or alloy steel. Ferrous alloys are the type of steels in which the elements like aluminium, boron, chromium, cobalt, copper, manganese are present in sufficient quantities in addition to carbon and iron to improve the properties of steel. The properties of ferrous alloys is it possesses high yield point and high strength. It possesses sufficient formability, ductility and weldability. They are sufficiently corrosion and abrasion resistant. Distortion and cracking are less in ferrous alloys. High temperature strength is greater in ferrous alloys. Then important ferrous alloys, nichrome. So nichrome means it contains 60% of the nickel, 12% of the chromium, 26% of the iron, and then 2% of the manganese. So the main properties of the ferrous alloys is corrosion resistant and abrasion resistant. That abrasion and corrosion are very essential and important properties, especially for the metals. So alloys, ferrous alloys having sufficient quantities of the abrasion and corrosion resistant. So nichrome and other ferrous alloys composition uses are discussed in next class. Thank you.